Hi, my name's Holly and I'm doing honours in biochemistry with the Huber and Otting group. And that's all I need to say. Yeah. Very safe. So there's this huge problem that bacteria can develop resistance to the current antibiotic medications. And to make it worse, antibiotic discovery is declining. And this means that there is a huge discovery void in the antibiotic world. So my project aims to fill that discovery void with peptide-based therapeutic medications. Our lab is able to produce these naturally occurring peptides and also genetically modify them to make them more effective and also to make them safe for human consumption. Basically, we do one of two things in the lab here in biochemistry. We do either cloning of plasmid DNA to make up mutations or find the DNA that you want, or we do protein expression. So today I'm going to be performing a PCR reaction and I'll show you what I do. You get a piece of DNA and an enzyme and you put it into an Eppendorf tube, you mix it well, and then you separate this solution into smaller PCR tubes. This is the machine we use to do PCR reactions. So I've set it up in these 5 little tubes and we put it in and we choose the sequence that we want in run. It's used for making mutations in DNA or to amplify a specific DNA that you want, which will then later be used to express protein in E. coli. Once the PCR reaction is completed, we purify it and send it to the John Curtin Medical School for sequencing. So what have I learned from honours? Well, it's a whole learning curve. Basically, you learn to communicate your research, and we practice communicating your research through daily or weekly activities such as journal club or progress meetings. I've also learned how to come up with your own solutions or problem solving. Basically, you're the only person who knows the most about your own project, so you can't always rely on other people to come up with your solutions. So next I'll be running an SDS page. It's a way to figure out whether I've got the right peptide or not, and a way to visualize it. So basically you load your peptide onto a gel and run it in an electrophoresis tank.
Troubleshooting is often part of the honours experience.
Once it's completed, you can confirm whether you have the correct peptide, and then you can use this peptide in the future. So once we know that we've got the correct peptide expressed, we have to purify it, and in our lab we have a machine called an FPLC. Basically, you put your peptide onto a column and it separates out all of the impurities and elutes your peptide in a specific fraction, and then you can perform analytical techniques such as NMR or mass spec after that. So after we transform DNA into E. coli, we need to keep them from growing too much, and I keep them in the cold room. So you want to come see my little baby bacteria? They grow on a transformation plate, and the point is they need to be enough concentration of bacteria to be able to express protein or to clone DNA. Well, basically at the start of honours, my mood really depended on my positive or negative results, but I mean, you can't really beat yourself up because a failed result sometimes means you've ruled out a theory, which can also be really positive as well. If I have a bad result, you try and take a break, go for a walk, get a coffee, come back and, problem solve an alternative path. It's time to walk up to the mass spec department. so it's up on the second floor. A mass spectrum is something that we use to confirm if we have the correct protein or peptide. By looking at the specific molecular weight, you can compare the result of the mass spec and your peptide of known specific molecular weight. So when we're looking at a mass spectra, we have to find specific peaks that correspond to your peptide and do some calculations to see if there's anything else going on. Well, I did honours because the chemistry environment is so great. I've been supported throughout my whole chemistry degree. I've made so many good friends and always been supported. It was the logical procession. I always just lose what I'm trying to say. I just need to